Hello everyone and welcome to this machine learning playlist. Today we are covering an important topic, so whether you're someone who is absolute beginner or you have some experience with machine learning, this playlist has been designed in such a way that it will be easy to follow for everyone. Also packed with lots of values and information, and it will be really helpful for you, especially if you're preparing for a machine learning based job role like data analyst or data scientist. So please subscribe to the channel and drop a like below to support our work. And without any further delay, let's get started with today's topic. Hello everyone and welcome back to this playlist of machine learning for beginners, where today we are going to cover the topic of naive Bayes classifier. So if you're someone who is new to the channel and watching this topic randomly, then I request that you access the entire machine learning playlist. I will provide the link below in the description for you. And also please do not forget to click on the subscribe button if not yet subscribed. Although it is absolutely free for you, but this will help us a lot to keep on bringing this kind of content. So before I get started explaining you that how this naive Bayes classifier actually works and give you a breakdown for everything that you can see on your screen, let's try to cover some prerequisites or basic stuff which is really required before we understand all this. So yes, this video is going to be slightly longer compared to previous videos, but trust me, it is going to be worth it. So there are few prerequisites that we need to get in place before we start learning about naive Bayes classifier. And let's start first with independent and dependent events. So independent events are nothing but an event where the outcome is not related to the outcome of previous event. For example, tossing a coin. If you are tossing an unbiased coin, then the outcome has nothing to do with the outcome of the previous toss if the coin is really unbiased. And the same goes with the event of throwing a dice. However, on the other hand, in case of dependent events, the outcome will be impacted with the outcome of the previous event. And let's try to understand how. Let's consider this box which has 6 yellow balls and 4 red balls. As a first question, if I am asking you that what is the probability of getting a yellow ball out of this box, then it will be 6 by 10. Because we have 6 yellow balls and the total number of balls that we have within the bucket is 10. By the way, if you're someone who is not at all familiar with the basic concepts of probability, then I would suggest you to watch a specific video that I have uploaded in my channel, where within only one video I have covered all the basics of probability, all the basic things that you need to know to understand probability related concepts within the field of machine learning or data science. I will try to add a card on the screen and I will also provide the link within the description box. Okay, moving on. So let's say this event has happened and you have already picked this yellow ball out of this box and now it is no longer there. So the total number of leftover yellow balls is 5 and the total number of balls we have within this box is 9. And now I'm asking that what is the probability of picking another yellow ball? Now this probability will be changed to 9 by 5 because we have only 5 yellow balls left out of 9 total balls. And this is an example of dependent event where the probability of picking a yellow ball has been impacted by the outcome that has already occurred from the previous event. And now if I will ask you that what is the probability of picking 2 consecutive yellow balls, then the answer will be the probability of picking first yellow ball multiplied by the probability of picking second yellow ball. After resolving this, you will get this value, which means out of this box where we have 6 yellow balls and 4 red balls, if you are being asked that what is the probability of picking 2 back-to-back yellow balls, that will be 1 by 3. So it is very important that you need to be clear with the concept so far. If not, then I would suggest kindly watch again the previous part of this video. And if you're clear so far, then let's move forward. And now we will learn about conditional probability. So the concept of conditional probability says what will be the probability of event B when A has been happened or A has been given. Let's try to understand the same by the context of this example. So the formula of conditional probability says that what is the probability of event A when B has already happened or the information for B has already been given. If we try to transform this formula with this example, then it will look something like this, that what will be the probability of choosing the second yellow ball provided the first yellow ball has already been picked, and we have seen the value for this particular term will come out to be 5 by 9, where the first yellow ball has already been picked out of the box. And in order to calculate the same, we need to calculate this particular term, which is probability of B intersection A divided by probability of A. Therefore, going by the above example that we have seen earlier, the probability of picking second yellow ball, provided the first has been already picked, the same formula will be resolved like this. Probability of picking second yellow ball and the intersection of first yellow ball divided by the probability of choosing first yellow ball. If we do the maths, then we need to know about the value for these two terms, probability of y2 intersection y and probability of y. So let's go back and check that. Probability of y intersection y2 is 1 by 3 and probability of y is 6 by 10. So let's plug these two values to the formula. So at the numerator term, I am going to place 1 by 3, which was the initial value for probability of y2 intersection y, and at the denominator part, the value is 6 by 10. So it is 6 by 10. If I try to bring this part parallel to this, then it will be look something like 1 by 3 and the fraction will be flipped in this way, 10 by 6. And if you try to resolve this, you will get the value of 5 by 9. So this should be the value of probability of choosing second yellow ball when first has been already picked. And when we are checking here, it is the same value that we have got initially, 5 by 9, probability of choosing the second yellow ball, which means this particular formula of conditional probability is actually working, and we have just proved how. Okay, so far we are clear with the concept of independent versus dependent events. We have understood the concept of conditional probability as well. And on the top of these two concepts, now we will try to get the understanding for Bayes theorem. And we need to understand this part because this is the core functionality of the naive Bayes classifier. So let's try to understand what is the Bayes theorem actually. So we know as per the conditional probability that the probability of A where B has already happened, the formula will look something like probability of A intersection B divided by probability of B. And the same thing can also be denoted as probability of B intersection A divided by probability of A. And that term will be equals to probability of B where A has happened, which means probability of A where B has happened and probability of B where A has happened are actually the same thing, or the probability will be the same. Therefore, considering this particular part, probability of A intersection B will be equals to probability of A where B has happened multiplied by probability of B. So in order to derive the value for this particular numerator term, all we are doing is we are sending this denominator term to the left hand side, and this is how this term is being derived. Similarly, the value for this particular term will be this multiplied by this if we send it over here, and this is what we have right here. Probability of B intersection A, which is this part, is equals to probability of B where A has happened, this one, multiplied by probability of A. And since we already know that the probability of A intersection B and probability of B intersection A are actually the same thing, this is why considering these two equations, we can say that the probability of A given B multiplied by probability of B will be equals to probability of B given A multiplied by probability of A, which means this term becoming equals to this particular term. And if you try to resolve this equation, then you will finally get the Bayes theorem, which is used in naive Bayes classifier. If you are wondering that how this equation can actually help us in order to classify between two classes, or let's say more than two classes, then that is something that we have not explored yet. But trust me, that will be simplified for you within this lecture only. But first, you need to make sure that you are absolutely clear till this point, that how we are deriving the Bayes theorem. If you're not clear till this point, then try to rewatch the previous part of the video. And if you're clear so far, then let's try to move further where we will understand how this equation is actually helping us to classify between two classes. So we are already familiar this Bayes theorem part, and we have seen that how this particular equation is being derived. So of course, now it makes sense to us. And let's consider this imaginary data set which has three features, F1, F2 and F3. And considering these three features, we need to predict for the target variable, which has two classes, either 1 or 0. And now we need to train the knife-based classifier in such a way that if it is given with the value of these three features, it should be able to predict or classify the value for the target variable. So the most important part is to understand how this particular Bayes theorem formula is being transformed in such a way that it can do the classification for us. Please pay attention over here. So we are checking the probability of class 0 given the values of feature 1, feature 2, feature 3, and this is what we have at the left side of this equation of Bayes theorem. Probability of A, which is probability of a given class, where B is given, the values for these features are given. Okay, on the right hand side the formula says probability of B where A is given. So probability of feature 1 where class is given, probability of feature 2 where class is given, probability of feature 3 where class is given, multiplied by probability of A. So multiplied by probability of class 0 divided by probability of B, which is divided by the probability of the given features. And exactly the same way we will do the same calculation again, but this time with the class 1. And after resolving this particular term, this entire formula, let's say if I get the output as 0.03, and let's say here if I get the output as 0.08, then we will go with the class of the higher value. So in this case, the final decision or classification given by the knife-based classifier will be class 1 because it has come up with a greater value upon resolving this entire term. So this was more or less the idea around knife-based classifier. I have tried to keep the mathematics part on the lower side as less as possible so that as a beginner you don't get scared of this topic, and hopefully now this will give you some idea to understand how this algorithm is actually working. Let's go through the advantages really quick. The algorithm gives every feature the same level of importance, assuming every feature contributes equally to the result. The algorithm is very quick as it requires less training time. This can be used for binary and multi-class classification as well. And this algorithm is really good in terms of handling categorical features. Talking about the disadvantages, knife-based assumes that all predictors or all the features that we have within the data set are independent, which is a very rare situation. This limits the applicability of this algorithm in real world use cases. This algorithm faces the zero frequency problem, where it assigns zero probability to a category variable whose category in the test dataset wasn't available in the training dataset. So it would be best if you used a smoothing technique to overcome this issue. And lastly, this does not work well with high dimensional dataset for sure. So for a dataset where you have like 20, 30 or 40 features, it would not be suggested to use this particular technique. So that was it for today's lecture. I hope that you found this video helpful in order to gain the understanding on this particular algorithm, knife-based classifier. Going ahead, we are going to explore more interesting topics like decision tree, random forest, and other bagging and boosting techniques. So please make sure that you subscribe to the channel. Also click the bell icon so that you can get notified every time I'm uploading a new lecture. Thank you very much for your time today. See you in the next lecture.